Hello friends, welcome to InfoStreet channel. Today's our topic is some important questions for a 5 marks and 2 marks for a exams. Okay, let's see the physical chemistry 2 to 5 marks question answers one by one. So there are some of important question answers are here. So let's see one by one. Here first one is, what are ionic covalent solids? Give an example each. The answer is ionic solids. Definition. Let's see the definition first. Solids formed by the electrostatic attraction between positively and negatively charged ions. Here plus ions and minus ions are charged. Okay, let's see the bonding of these ionic solids. Solids ionic bonds are metal plus non-metal. Here metal means like a iron, sodium like this, non-metals like a chlorine like this. Okay, let's see the properties of these ionic solids. Here are the ionic solids but properties are high melting point and high boiling point. For ionic solvents, this here a high melting point and boiling point, and hard and brittle. Brittles means like example glass like this it will come. Okay, and conduct electricity in a molten state or when dissolved in a water. Here ionic solids are conduct electricity when we dissolve solids in a water. Okay, and soluble in water. Most of ionic solids are soluble in waters. For example of ionic solids are sodium chloride NaCl, potassium bromide KBr, magnesium oxide MgO. Here sodium is a solid and chlorine is a gas. Like this it will be differentiate. Okay, let's see the covalent solids on the same. Okay, here definition of a covalent solids are solids where an atom are bonded by a covalent bonds in a continuous network throughout the structure. Okay, solids where atoms are bonded by a covalent bonds in a continuous network throughout the structure. Here let's see the bonding of these covalent solids. Strong covalent bond, non-metal plus non-metal. Here both are non-metal. Okay, so let's see the properties of this. It's a very hard. Example diamond. Okay, it's a very hard. High melting point and generally poor conductor of electricity except graphite. Here this covalent bond are a poorly conduct electricity, but exception is graphite. Okay, insoluble in water and most solvents. These covalent solids are insoluble in water and so many solvents are insoluble. Okay, these are the covalent solids properties. So let's see the examples of covalent solids. Like here diamond carbon, quartz silicon dioxide SiO2, graphite carbon C. These are the example for a covalent solids. So let's see the second one question and see that's definitions also. Okay, define point and line defects in a solids. Here these are the common questions we will get in exams. So let's see the definition also for this and also examples for this. First see the questions. This is define point and line defect in a solids. Point defect. Let's see the definition of point defect. Point defect is a defects that occur at or around a single point in the crystal lattice. Okay, let's see again one time. You can see that define. Definition is defect that occur at or around a single point in the crystal lattice. Scale, atomic scale, localized. Okay, types. Point defect types are vacancy defect, interstitial defect, substitutial defect, substitutial defect, Frankel defect, and Schottky defect. In PU also you studied that Frankel defect and Schottky defect, how it will be. So it's like that. Okay, let's see the one more question in that is line defect in solids. Okay, so line defect solids are in a dislocation, sorry, it's a mistake. Okay, definition of this line defects are defect that involve rows lines of atoms in a crystals. It's like crystals, if they means in a row. Defects we can see it in a row. Here defects we can see it in around a single point, like a 1, 2, like this, we can see that. So let's see the examples for this also, then you can easily understand this. If these are the atoms, here defect will be only singles. So these are the example for a point defect. But here line defect means defect will be occur in row. Okay, in this way we can differentiate these things. Okay, scale of this line defects are one dimensional extending through the lattice. Okay, types of this are edge dissolution and screw dissolution. Edge dislocation and screw dislocation. Okay, so one more question we can see that here. This is also 2 marks. For 2 marks it will be it may come for 2 marks. So let's see it. Silicon is a widely used as a semiconductor material. Why? Okay, our question is silicon is widely used as a semiconductor materials. Why? So let's see the why it will be morely conduct in a semiconductor. We use in a semiconductor. Abundance and cost. Silicon is a second most abundant element in the earth crust. So that's why it is inexpensive and easily extract from a sand. It is cheaper and also we can extract it from sand easily. Okay. Suitable band gap. Silicon has a band gap of 1.1 eV, which is ideal for electronic devices. Okay. Thermal stability. Silicon can operate over a wide temperature range without degrading. It has a high melting point. 1440 degrees Celsius and chemically stable. And fourth one is easily to fabricate. It can be easily doped with the elements like a phosphorus or a boron to modify a conductivity. It forms a highly quality oxide layer SiO2, which is useful in making a transistor and integrated circuits.